Hi everyone, thank you for being here. I am Christos Christodoulou. I've been part of the Cyprus Institute for some years, mainly for assisting with collaborations with the industry sector, particularly in fields like machine learning and high performance computing. At the moment, I am also working with the Cyprus Institute part-time. I also have another job in the healthcare sector. Doing a lot of stuff there again with AI and trying to help, using this technology to help patients and help healthcare providers do their job better and discover drugs better and so on. I've been working in this industry, let's say, for a couple of years. I had the opportunity to work in building products or maintaining products that contained machine learning algorithms inside. And the talk today is going to be about how to treat, let's say, a machine learning algorithm and how to incorporate it in a product somehow or service. And so it's going to be partly about the product, let's say, management or project management procedure based on what I've seen these years, and also it's part's going to be about considerations of what to think about when you want to use large language models in your product. Again, thank you for coming. Let's keep the session interactive. I like this approach. So I will ask you some questions when the time comes. Okay, building products powered by large language models. The item is a bit like this. The CEO's vision. I will explain you what that means. Then it's a bit about the whole kind of process of thinking about the problem and then thinking about the solution and trying to implement it. A bit about large language models and a bit about ethics. Okay, first question here. So who of you here have used already ChatGPT through the interface or through programmatically? Okay, and thank you. And who of you tried to build an interface on top of it, like a service or a product using the API, let's say, trying to interact with it, programmatically. Okay. I think the main points here is how to not just use the interface where you can log in the OpenAI's ChatGPT interface or Google Bard or Anthropic Cloud. A lot of them are out right now, where you can interact using the user interface, but actually, write some code and incorporate that code within a product where you can build maybe a layer on top of ChatGPT that will produce answers in a way you want it to produce answers, or organize information in other ways. So the most frequent cases right now in industry is creating AI assistants, of course chatbots, and many other areas there, but mostly what is out is in Stu. Okay, before continuing, I want to mention this graph. So at the moment, generative AI is at the peak of inflated expectations. So the graph on the right is a bit small, but the first peak you see there, or the only peak you see there, is generative AI on top, which is this peak that people in the industry are talking about. And the color of generative AI there is blue, which means it's going to reach the plateau of the throw distribution in 5 to 10 years from now. What that means is that people right now have very high expectations of what they can build with these large language models or generative AI in general. There are many nice things that people can build, but also very harmful things as well. So just keep this in mind for the the next. Okay, wrong kind of contrast for the font. Okay, so the story here is that you work in a company, and at some point the CEO of the company thinks that, okay, let's convert our company into an AI company. Why? There are many reasons to do that. If a company is, labeled as an AI company, the valuation of the company, of course, goes up. The investors, look at the company with a different eye. So this is the CEO's vision. Of course, the CEO thinks about it. He's at home thinking about, okay, how to do that. Goes back to the team in the office or remotely, and then says, okay, let's do that. What's the most frequent thing there is that there will be a lot of pushback from the team, from the product managers, from the engineers, because it's not easy to maintain AI products. It's not that easy, and it might be harmful for the company at the end. So after a lot of discussions, and a lot of pushback, the CEO decides, okay, let's not build an external product, but let's build an internal product first, for our employees. And this is actually a common tactic. So there are a lot of companies that try to build AI, to use AI tools for improving the productivity, let's say, of their company. They are using the methodology to get the knowledge to start, getting their hands dirty, build AI products, and then they think of the next step. Okay, let's build AI products for our maybe externally facing clients. After a lot of consideration, the team and the CEO came with the concept of the smart coffee machine. So the way they thought about it is that, okay, let's build a coffee machine let's have a coffee machine that can engage in discussions with employees and can recommend coffee beverages based on their mood. So but that was the idea. So an internal product, maybe a fun approach to AI. Let's do that. Okay, before starting building something, that is the kind of trying to understand the problem first, trying to discover what you want to actually build and when to build it, and what resources to use, and so on. This can be kind of conceptualized in a problem framing, let's say, time. And the way this starts is like defining the problem. So what is the problem in the heads of the CEO, the team, the product manager? One of the problems is that the coffee making is a maintained procedure, limited personalization. The employee engagement falls during work. Office experience not optimal. Of course, the company is not yet an AI company. So these are part of the kind of thinking procedure of kind of defining the problem. And as soon as you define the problem, you start defining the objectives of what your goals are. So one of the objectives could be, okay, make the coffee making more fun, increase employee engagement, improve office experience, increase organization's innovation level using AI, and of course make the company an AI company in the head of the CEO. Another thing in the product development kind of process is to think about who are you building this for. So who are the users? They're going to be internal users of the coffee machine, and employees of the company. And you start thinking of, so the whole team, engineering, product, data science, executives, they start thinking about the high-level approach of this. So machine can detect user mood during interactions, can recommend coffee beverage based on mood. Coffee beverage should come from a preset list of what the coffee machine can offer. The users should interact with the machine using voice. The machine should interact with the user using voice. The system will comprise of a set of existing models and API calls to make this work. So at the end, that's kind of the problem framing. So thought about all these things. There were some iterations, and as soon as this was framed, we moved to the solution framing. So how to build this. But that always has to be the next part.
then you start setting milestones, like, okay, voice interaction should be built in 1 month, mood detection 2 months, beverage recommendation 3 months, and so on and so forth. You think about when you deploy this, you think about when you test this internally or externally, or in kind of beta versions of the product, and so on. You start thinking about the success metrics, like, okay, how do I measure that? Okay, what I built is actually successful. So you can devise a lot of metrics there. Some examples, like you want to say, okay, minimum 80% of employees interact with the smart coffee at least twice a week. Minimum 90% of them find the interface user-friendly. You can get that feedback using some sort of surveys. And the minimum of 80% in the user satisfaction, again, using some sort of surveys. You can devise some performance metric, like average latency, uptime, feature utilizations. At the end, you want the users to use the feature and not just use the coffee machine. So you want to use the recommendation feature, let's say, of the machine. You build a metric on that. You can have health and cost-saving metrics. For example, minimum 10% reduction in overall coffee consumption. Let's say that there are employees that are anxious, or they had already a lot of coffees that day. You want to reduce that, and let's say opting for healthier coffee options when recommended. At the end, the team and product manager and the engineering, they come with some functional requirements, thinking, okay, how should this product function? I won't go through this. This is usually built using a prioritization in mind, because in a lot of these situations, when you need to build something, you need to build it in a certain time frame. So you want to iteratively approach it, so that you can build something in the amount of time you have. And of course, there are some non-functional requirements like performance, scalability, security, and the responsibility of your service or product. The responsibility part is maybe an additional part when you want to build the product using an LLM, large language model, where you have to think about the output from the machine does not contain any toxic text or biased text, and so on. Of course, when you do that in the context of a company, you need to align at all times with all the stakeholders, the people that they're going to build that, and the people that they're going to market that, and everybody. So you have to do this continuously. Otherwise, you start, maybe sometimes the engineer will start building something that's not what you intend them to be. You can do this in various ways, but the main idea here is that you need to continuously align with the stakeholders in order to build the thing that you want to build. So during this process, it becomes apparent that, okay, to build this thing, we need to use some sort of AI, and the idea comes to using large language models. So the approach to go at this time that this technology exists is to use it because it's complicated to use it, but it's also simple to use it as it stands now. It's more complicated to use older versions of large language models that do not use this generative approach. So at the end, the team would come together and say, okay, let's build this using a large language model, for example, GPT-3 or GPT-4, and so on. And this is the first part of the talk. Let me know if you have any questions up to this point before going to the next one. Okay. The next one is about considerations that the team would have when going to build this product or build this kind of service. So one of the main considerations when developing things using large language models is that you need to spend actually little time coding, but a lot of time doing prompt engineering. which is what Konstantin talked also before. So you need to engineer the prompt, so the input that you will give to the large language model, so that you can get the best output possible when the machine interacts back with you. And the problem there is that natural language is much more ambiguous than programming language. And the thing is that if you want to create a toy using a large language model, let's say you want to use ChatGPT and build an interface on top of that, it's quite easy to do it. You can play a bit with what prompts to use, and you can create that. But to put a product in actual production, then things become quite trickier because of this ambiguity and a lot of other things that we'll discuss in a bit. So again, it's quite frustrating as a developer to write in natural language. It's great for user experience, so the user at the end will use voice to interact with your product. But to actually build that, it's quite frustrating. So it's one of the considerations anyone would think when going to build such kind of a product. Okay, one of the problems is the ambiguity. Even after designing prompts to output a desired format, the adherence to the format is not always guaranteed. And why this is a problem? Because the applications you build on top of these LLMs, they usually expect a certain format of the outputs, because they're going to get that output, which is text. They are going to parse it and they're going to use it in the application. And you have to find ways to solve this problem or build safeguards to this problem. An example is this one. So I'm asking ChatGPT here to evaluate an essay, and I'm telling it, okay, output in the following format, like score, curly brackets, score out of 10, and I think it writes and not anything else like on the right. So on the left, it gives a score of 7 out of 10, everything nice. So then the programmer that's going to write the application on top of this output will get that 7 out of 10, and will be able to serve it in the application, be able to use it during, let's say, the voice interaction of the coffee machine with the user. In a lot of cases, I just provided 4 words there and asked the same evaluation. ChatGPT answered that it didn't follow the format I wanted, but it answered the text you see there, that it cannot provide a meaningful evaluation. So you have to, as in all software kind of development procedures, you have to build kind of safeguards to see what to do when you get this output from these models. And it's not always straightforward. Sorry? Yeah. There is, again, this ambiguity would cause also problems in the user experience, because LLMs are probabilistic, and the same output is not always guaranteed for the same input. And why this is a problem? This is actually a huge problem when building, products for users, because users expect this uniformity when interacting with products. And if they don't get this uniformity, the uniformity is likely to abandon this product. In our case, it's an internal product. I mean, it's fine if they abandon it, but if you want to build out something for the market out there, you need to think a lot about this. Okay, this is very long. On the left and on the right, it's exactly the same text. On the left, I get 8 out of 10. On the right, I get 7 out of 10. There is no change. And this is a behavior that a lot of people has seen in cases. One of the biggest problems is what they call hallucinations. The best kind of description I've heard about hallucinations is this one. So creativity is what we call it when we like it. Hallucinations is what we call it when we don't like it. This is by Mark Andreessen. If you watch the Lex Fridman podcast, it's in there. It's quite interesting. But it's actually a big problem. So it refers to the phenomenon where the LLM generates incorrect, nonsensical, or not real text, but it's very hard to distinguish. It looks like it's fine. It's a problem because again, it limits the trust the user have with the product. All right. So we talked a bit about, some challenges. We're now talking about some mitigation to these LLM challenges and what kind of people have been using the past, let's say, a couple of years and mainly the last 6 to 9 months. Okay, one of the common things that they do is, it's this kind of a temperature setting. So you can make the model completely deterministic by setting this configuration to temperature 0. This means that you kind of force the model to give you the same response when you provide the same. You can use ChatGPT using their API. You can write some small configuration and say, okay, every time I give you this input, don't be creative, be very deterministic, give me the same output. Of course, this has some drawbacks. It can harm the user trust to the product because these small configuration affects the entire behavior of the product. You might have a small text, and then by changing, some the tense in the text, when you have this temperature setting, it might give you a completely different response. A lot of companies work on kind of circumventing the ambiguity problem. They build kind of in their software development process, they build ways to go around it, so that they instead of avoiding to live with it. For hallucinations, again, there are a lot of mitigations have been thought. One thing is to kind of clean up the data, fine-tune the model, but this is not a good option for people or companies with not a lot of money. It's very costly, and in many cases impossible using commodity hardware. People add human intervention to check and conditionally regenerate the results. So you kind of have a human in the loop. There's a response coming out. It checks for hallucination and then might give it back, or can sample some of these responses. And another thing is kind of control generation by providing enough details and constraints to try to bound or limit this hallucination problem. So the thing is that, if you give a lot of details to the prompt, then is one way to kind of reduce the probability of extreme hallucination, at least. What people have, again, Konstantin talked about, the whole prompt engineering is becoming a discipline right now. There are, prompt engineers kind of job positions being advertised. What companies try to do is kind of have a systematic approach to prompt engineering. For example, prompt evaluation using featured learning. You provide some examples in the prompt and assess whether the large language model actually understands your example. And then you can check if it can generalize it from these examples in the way you want it. For example, given a text, give it a happiness score. So these are some examples. And then at the end, you give it kind of a test to understand whether it makes sense for you. As you see, the output there seems reasonable. So that is a kind of a way to test the response there. Another way is prompt versioning, the way you version, you use kind of version control systems to version your code. A lot of your version, their prompts, they try to store all the prompts and the output, and they timestamp it so that they have all this tracking. And a lot of things people try to do is to optimize these prompts. Again, kind of these step-by-step methods. The chain of thought is a way to make the output better by asking for the large language model to describe how to arrive to the answer. It has, of course, some trade-offs. It can increase latency and cost. Other ways people try to optimize for prompts is to generate many outputs for the same input and pick the final output by kind of voting evaluating and voting what's the best output to use. Again, all this, so the more tokens you get out of the model, the costlier it comes. And there is a lot of work being done in optimizing prompts. There is this recent paper, I think it's a week old, large language models as optimizer, and DeepMind, in this paper, it claims that it got 9% accuracy increase with a simple AI-generated prompt. Do you have any idea what the prompt was? Okay, so the prompt was take a deep breath and work on the problem step by step. That was it. There are a lot of memes out there now, like people saying, okay, let's enroll LLMs into yoga classes, try to make them feel nice so that they give us better outputs. But yeah, though this is a kind of a chain of thought kind of way of prompting the LLM. And yeah, they found that, okay, this works. They're not sure why this works. But at least the way understanding, okay, by giving, you give a prompt to the model, the prompt is converted into other embedding, and it falls into a latent space somewhere. And it's a bit like Google Maps. When you try to get direction from Google Maps, if you say I want to go from Lemesos to Nicosia, it will give you a direction to go from one place to the other. If you tell it I am at the municipal garden, I want to go from municipal garden to the center of Nicosia, it will give you an even better and more useful output, which is the direction. You tell it I am at number 10 on this street and I want to go at that other street in Nicosia, it will probably give you an even better direction to go there. So, I mean, that's an analogy. Analogies don't always work nicely, but I mean, the more accurate or the more detailed prompt you give, at the end, the embedding falls closer to a starting point, I guess, in this huge latent space, and from there it will start to give you a better output. Okay, how much time do I have? 5 minutes. 5 minutes. Okay. Costs are when building these products, you have to think about costs. So the more detail in the prompt, the more expensive the inference. Usually model providers such as OpenAI, they charge for the input tokens and also for the output tokens. So in every time you have to assess whether the costs are sustainable for your use case. I went back. The latency is another consideration. Input tokens are usually processed in parallel, so that's usually fine because the input length does not affect the latency that much. But the output tokens are usually generated sequentially, which that affects the latency. Some example is, for example, GPT 3.5 Turbo. The latency is half a second for one output token, and it goes to 1 second for 20 output tokens. So the latency is quite a problem in a lot of cases. Okay, user experience patterns. Again, we discussed a bit about user experience before. People start talking about what they call defensive user experience when building AI products. So it's a design strategy that acknowledges ambiguity or hallucinations that can happen during the user interaction with an LLM product. The goal of this kind of strategy is to anticipate and manage this in advance by guiding the user behavior, averting the misuse and handling the errors. Because again, the LLM-powered products might violate the principle of consistency or uniformity of what we called before. There are a lot of guidelines out there by Microsoft, Apple, and Google. So a lot of people doing work in actually designing products using AI or LLMs. They try to follow one of these guidelines. And can help you in other ways, increase accessibility and friendliness, trust, and have a smoother and more enjoyable experience in this kind of in this environment where LLMs can be kind of uncertain. Okay, last thing I wanted to talk about when it comes to LLM consideration is this retrieval augmented generation, or RAG. This is becoming quite frequently used again in an industry when you want to use your data and kind of ask the model questions about your own data, which they can be private data as well. So one of the big problems with LLMs is that they are stuck, right? So for example, GPT-3 was trained up with data from Wikipedia, Reddit, and other sources online, some books, up to 2021. So after that, you can either retrain the model, try to fine-tune the model, but again, the problems there are kind of the costs. So the idea here is to add external data to enhance the input of the model, to provide more richer content to improve the output, sorry, not the input. It can help reduce hallucination by grounding the model to the retrieved context and try to increase factuality. So people are actually using this on your questionnaire before they are using this method to actually provide also references to the output, because you can give the model a lot of your documents, and it can provide, when it gives the answer, it can say, okay, I provided the answer based on page 5 of this document you gave.
Sources more credible.
You cannot add it inside the model. This is an external data source. You can use it to interact with the model, but with this methodology, you don't really retrain, you don't give additional data to train the model, but you actually give it as input to provide a better output to you. And there are ways to, build this so that the user experience becomes, there are also applications outside you can find, and the user experience is really nice. But yeah, you can add as much of data as you want.
But you can add more credible sources.
You can add whatever sources you want, yeah.
But you cannot remove the uncredible ones.
You cannot remove whatever the model was trained on.
Right.
But you can try to tell the model, okay, give me an answer based on this 1,000 documentation I gave you. You can use the knowledge you kind of extract. It's built on when you are trained as a model. But I mean, try to give me a factual answer by sticking to this data. There is a bit how it works. So there's a pre-processing step. You have new documents. Let's say you have you're at a company and you have documentation of your product. So the documentation changes once every 2 weeks, once every month. So you want to build a chatbot in this case, where the chatbot has information about this new documentation. So when there is a user asking questions about your product, it can get advice from this new documentation. So you could do a kind of data processing step. You get the documents, you chunk it, and you create embeddings of these chunks of documents, and you insert into a database. So in there, you start the embeddings and also the chunk of your documents, the chunks, in what is called a vector index. So it's kind of the index where these documents are stored. These databases are also becoming very popular now. They are called vector databases, and they contain all this information. So when there is a user coming in and asking a query, okay, tell me why your product does this. This query is embedded again using the same embedding model as the chunks of documents. And then what happens is that with this embedding, it enters the vector database and it tries to find similar documents or similar embeddings based on the input you provided. So you provide some input, it creates a vector of the input, and then it searches to find, okay, I'm trying to find 5 more documents that have similar meaning as the input. So it collects this document, it ranks them, curates them, creates embeddings, and then when providing a context to the prompt, to the LLM, the prompt, it does not only use the prompt, which you can specify some text you want. It provides of course the query of the user and also all this retrieved information. So the prompt at this point becomes a longer text containing more information, so more details. The query, the question from the user, information from the vector database to be used to give answers to the user back, and some more things about how to build the prompt. You call the LLM, and then after that you provide that. In a lot of cases, the output makes more sense than when not doing this retrieved information generation. And again, some perspective from the industry. So there was a survey being done from Sequoia Capital, and 88% of the participants believe that retrieval, so retrieved information from external data sources and combining these mechanisms with LLMs, will be a key component in their LLM technology stack in the future. Again, this is one way to approach this problem using this retrieval augmented generation, but it's becoming a popular one. So, okay, at the end, I know I don't have much time, but okay, the CEO comes and says, let's extract what people feel about their work by analyzing their conversations with smart coffee machine. So in this case, let's say the CEO is asking for the engineers to kind of eavesdrop in what the employees say, kind of try to understand what they're thinking about their work. Of course, the CEO can say, okay, this is to improve work conditions, finding toxic behavior and harassment. Of course, there's nice things you can do with collecting this, information, but of course, you can do a lot of bad things by collecting this information. So I'm coming to the last point of the presentation. It's about thinking about legal and ethical issues. So whenever these kind of requests come, when you want to build in a product, you have to think about, okay, is this legal? I kind of researched that a bit, and it seems that it's legal in the US to eavesdrop into conversations or video record people at work. But again, it's a consideration. You have to think, is it legal? Is it a responsible thing to do as well? And is it ethical? So employees might share sensitive or personal information. So again, you have to consider the ethics when building such things. And you have to consider, okay, what can go wrong with all this? And that was it. Sorry for the Any questions?